does the first sentence give me? Taylor.
I think H equals K times S.
H equals KS. Now, sometimes we do K over S. Not this time, because this says directly. So it's K times S. Inversely would be K divided by S. All right, so there's our equation. All right, let's look at number 2. If you are 60 inches tall, you wear a 7.5 shoe. So what does that say? 60 tall equals K times 7.5. So K equals 60 divided by 60 divided by 7.5, 8. So what's our equation? Instead of H equals KS, it's H equals 8S? Third question, or third sentence. What size shoe does a person 68 inches tall wear? And what would that look like? 68 equals 8S. So S equals 68/8, which would be a shoe size of 8.5. Everybody remember that from yesterday? Okay. I just made that problem up and it worked out so nicely, I'm going to write it down. Okay. Now, get out your note sheets because we are going to be busy users today. Turn to the back of page 16. Believe it or not, you're going to graph this without a calculator. Whoa. Well, the first thing I'm going to do is to put 3 dots on this x-axis. I'm going to put 3 x values on my grid. Anybody want to take a wild guess where those 3 dots might go? Just take a guess. Taylor? Close. Actually, it's the opposite of that. So it wouldn't be 1, it would be -1. It wouldn't be 2, it wouldn't be -2, it would be 2 and 3. I'm going to share something with you that's really important. Polynomials, and that's what this is, a polynomial, they have particular behavior, graphical behavior, that never changes. This is a cubic polynomial. What do I mean by that? What am I talking about? How did I figure that out? Cubic. There's 3 factors. If I were to multiply this all out, which you never have to do, ever, but when you're graphing anyway, if you were going to multiply it all out, you would have an x cubed, wouldn't you? If you are an odd degree polynomial, so whether it's x to the 3rd, x to the 5th, x to the 7th. If you are an odd degree polynomial, you start down and end up. Think about your BFFs. What did the cubic polynomial look like? Didn't it look like this? Yeah. It starts down and ends up. This is the way odd polynomials act. They start down and end up. So, we have figured out that this is an odd degree. We know it must start down. So it starts down here, and it comes up and it grabs this point. And then it goes through and it comes down and it grabs this point. Now, I do not know how high it goes. That is a problem for the calculus. You will figure, when you take your calculus class, you will be able to find that. Certainly you could find it on your calculator. But when we are sketching by hand, all we know is the curve starts down here. It goes through that first point. At some point it has to turn around because it has to connect to this point.
Excuse me for interruption. Is Harrison Frank in the room?
He is.
I need him to come to the front office, please.
Okay.
Thank you.
Come back as quickly as you can, Harry. Now, we're going to go through this point, and then you see you have to turn around pretty quickly to grab this one, and then sail right on through. And there is a picture of that function. Now again, you are not hung up about how high and how low. That's not our issue right now. You want a shape that looks like this. That was pretty easy, wasn't it? Let's look at the next one. Okay, could you do this one? It's kind of the same situation. What are you going to do? You start with dots. We're going to put the dots. Put a dot at -4 and always label those, boys and girls. Let's put a dot at 2 and a dot at -3. What's the degree? If you multiplied all your x's, you would have x to the third, x cubed. And we know that cubes start down here and end up here. So let's start down here. Okay? Go through that point. Then what are you going to have to do? Turn around, because you got to go through that point. And turn around, because you got to end by going through that point.
So does it matter like what order they're in? It's just like in the problem.
No, that doesn't matter. You gotta have them in the right order on the axis though. All right, let's look at the next one because it has a little bit of a different thing in it. Do you see what's different? It's got a squared factor. Now, are there still 3 factors? Is this still an x cubed problem? So it's still going to start down and end up. The difference is you're only going to have 2 dots. Because that parentheses gives you the same dot. You can't put it on there twice. Squared factors behave differently than regular factors. Regular factors, when you hit the dot, you go right through it. Hit the dot, go through it, hit the dot, go through it. With a squared factor, we're starting down, but we don't go through it. We bounce off of it. If the factor is squared, you don't go through it, you bounce off of it. And then come down and go through that one. So I come up from the bottom, just like I always do with the cube. Always do with the cube. I come up from the bottom, But when I hit that point, instead of going through, I have to bounce off. Why do I bounce off? Because it's a square. Wherever the squared factor is, you're going to bounce off. Uh-oh. What do you notice about this one, kids? Okay, they're both squared, which means if you multiplied it all out, yes, Trey, it would be x to the fourth. Okay, now wait a minute. Odd degrees start down and up. Even degrees, x to the fourth, x to the sixth, x squared, start up, end up. Think about y equals x squared. What shape is y equals x squared? Parabola. So if you're even, you're starting up, ending up. So this curve only has two dots. And it starts up. Now, it always frustrates me when kids say, Miss Ford, how'd you know to start up? You've got to pay attention to how many x's you have. You have 4 x's. That's an even number. Evens start up and end up. Okay? Now, what do I do when I hit this point? I do not go through it. That is a squared factor. So I bounce off of it. But wait a minute, I got to get to that point. So I'm going to have to come up and somehow turn around. And I'm going to grab that one. And what am I going to do when I get to that one? Bounce off again. There we go. I don't know how high that is. I'm not worried about it. Starts up, bounces, connects, bounces, and we're done. Oh my gosh. Look at the next one. Kids, these problems look huge. Don't you feel so smart? Tonight when you go home and mom and dad say, what'd you learn today? What about one of these? They'll be very impressed. How do we start? We put some dots on it. Where are my dots going to go? -1, 2, -5. How many x's do I have? 5. Somebody said 3. I'm not talking about parentheses. I'm talking about actual x's. There's 2 of them here. There's 2 of them here. There's 1 of them there. Huh?
Some of those imaginary.
Nope. They're all real. So I have 5 x's. That is an odd number. So I am going to start down and end up. So here I go. I'm coming up. Now when I hit that point, I have to make a decision. Do I go through it or do I bounce off of it?
Go through it.
That dot came from this factor. What are you doing?
No, sorry.
Turn it off and put it away. How serious do you think your father would be if I emailed him?
I don't know.
Oh, I think you know. So from the bottom up to here, there we go.
Yeah, good.
Have we made a decision? Do we go through or bounce off? Go through. We go up a ways, turn around and come down.
Bounce off.
Now we bounce off of that one because it came from here. So then we go up and come down, grab this one, bounce off again. Now this one has a little twist to it. Literally a twist. How many dots on the number line here?
4.
Well, there's 4 X's, but there's only going to be 2 dots, right? There are 4 X's, which means start up, end up. Now, I'm going to go ahead, I'm starting up, I'm just going to come down, I'm going to go right through that one, right? Because that came from this. At some point, I got to turn around, and I'm going to pick up that one, right? Now, it is a cubed factor. Think of your BFF. When you draw a cube, it doesn't just go through the origin, it kind of squiggles, right? That's what's going to happen there. It's going to come up and squiggle its way through. Just make sure that you have a squiggle there. It's in your wrist. That's the shape. So, if it's a plain root, not squared or anything, it just goes right through. If it's a squared root, it bounces off. If it's a cubed root, it squiggles through. There's another one on here we'll practice again. But first G. Now wait a minute. How many X's are there? 4. There's only going to be 3 dots because one of them is squared. Four X's. Should behave like this, right? What did I do on this problem? What's out in front? It's a negative. What does a negative do to the picture? Flips it. So instead of starting up and ending up, this one's going to start down and end up. I do not want you to worry about the actual 2, but you have to pay attention to the negative. Okay, because the negative is going to turn it upside down.
What's the second?
The 2 stretches it. But since we're not looking at high points and low points, I'm not worried about the 2. But that would stretch it, make it taller, make those hills taller. All right, so what did he say? We're going to start now. Now, you got to pay attention. That dot came from this. So what am I going to do? Go through it. And turn around, come to here. That dot came from here. So what am I going to do? Go through it. Come up and grab this one. That dot came from there, so what am I going to do? And there you go. Alright, this has got everything in it. Right, here we go. Julian, should I confiscate that? You want to put it down then for me? Alright, here we go. Where are my dots, Steve? How many X's I have, Zach?
6.
That's even. How do evens behave? Start up, end up. But oops, what's this one got out in front of it? It's going to start down and end down. So here we go. Now, I'm going to pay attention. I'm coming up from the bottom, right? But that guy came from here. So I'm going to squiggle my way through. Here's my squiggle. See my nice little squiggle. Now it's going to go up and turn around and come down to this one, right? That came from that. So what's it going to do? It's going to go through.
It's gonna bounce off.
Going to bounce off and go on down. All right. You feel okay about that stuff? Yeah. Okay, now look at the next page. Because on the next page, you're going to do it backwards. I have drawn the picture, and you are going to write the equation. Another random point up here, and we're going to talk about that. But to get started, these are the points you're looking at. Tell me about your factors. Tell me about your parentheses. What are they going to look like? X plus 2, X minus 1, X minus 3. Now look carefully at your picture. Are any of them squared? This one has to be squared. Why does that have to be squared? Because it's bouncing off. Are you okay with that so far? Now, this is not a very specific equation. There are lots of equations that would behave like this. Let me draw another one for you in purple. That equation would have these very same factors. Would you agree with me? I need to know what number is out here in front that will make sure this equation goes through that point. Okay, so Lauren says I can already tell it needs to be negative. But will it be a -2? Will it be a -1/3? What will it be? How do you think I'm going to figure out this missing coefficient? Think about what you did on your quiz. This is an X and a Y. So I'm going to put 2 in for Y and 0 in for X. See what I'm doing? Whatever point they gave me, I put in the Y and the X, and now I'm going to work it out. 0 plus 2 is 2. 0 minus 1 squared is 1, and 0 minus 3 is -3. So So A times -6. So what does our A end up equaling? -1/3. So in the answer blank, that's what you write. Couple more, see if we can hang in there. All right. Now in the beginning, I'm not even interested in that point. I don't care about that right now. Right now, I need to get my parentheses set up. What will be in my parentheses? Plus 4, plus 2, minus 3. Nathaniel, you doing okay? Any of those squared? How do you know? Nothing's bouncing off, they're all just zipping through, right? So that's it. That would be the answer, except what's missing. I don't know what my coefficient is. This was the point 0, -3. So how am I going to find that point, or that coefficient? I'm going to put -3 in for y and 0 in for x. And I'm going to do the arithmetic. Four times 2 times -3. So what's our A turn out to be this time? What is it? 1/8, yep. Manageable, isn't it? One more. I'm not going to take the time to draw this one. We've got it right there in front of you. But let's start with our factors. How many factors will there be? 3? How do I know there'll be 3 factors? Because there are how many dots on the x-axis? 3. Jordan, you need to stand up and get that blood flowing. You look like you're getting ready to take a nap. What goes in that first parentheses, Jordan? Look at your paper.
X plus 2.
X plus 2. How about the second one, Jordan?
X minus 2 squared.
Now look at the next dot. Where's the next
Oh, X
dot?
was 0, I'm sorry.
So we could say x minus 0. Could we say x plus 0? Could we say plain x? Yeah, you do. Whatever you want. And in the third one, Jordan?
X minus 3.
Yep, there are the dots. Okay, you can sit down whenever you're ready. Any of them squared? This one squared. This one squared. Can you see that? See how the picture bounces off? If it bounces off, it's squared. At 3, it doesn't bounce off, so it's just plain. Now I need my coefficient. How am I going to find my coefficient? Look at the problem. What random point did they give you? So you're going to put 2 in for y and 2 in for x. 2 plus 2
4.
squared.
16.
2 minus 0.
2.
Well, 2 minus 0 is 2 squared is 4. And negative 1?
Negative 64.
So that's negative 64.
Negative 1's 34.
So negative 1 over 32.
So you're getting the negative 1 over 32, but you're dividing the negative 64. Right.
Got it? Now, quickly, our last minute here. Take a look at the picture there that we just did. Where does it start? Up and ends down. Does anything start up and end down? No, unless it is a negative I. Right? And that's what we got here, a negative I. All right, tomorrow we'll start on part 3, factoring.